Distributed treatments example. The following scenario that I'm going to explain is very related to an exercise that you have to do later. So this exercise is not a simple exercise. It's let's say it's an advanced exercise for people who have done the advanced course. And in this exercise, we're going to see that we have to work with several containers, and we're going to have to send the lines from one process to another one. So it's very important to take good attention of this scenario. This scenario includes 4 different classes of processes. We're going to have one class of process that we're going to call the causal process. Here in this presentation, in order to explain this scenario, I've represented each one of these classes of process with a specific color, and besides we've given them a specific name so that it's a little bit easier to follow. So basically we have a causal process. This one and this one, the lines are going to be created and they're going to be deviated or transferred to other classes of processes. We're going to say that when I create in the causal process lines in a group of fields, each one of these lines has to be derived to a different class of process, to a different process of 3 different classes of process. So my lines can be of 3 types, and we're going to call them lines of the type S, lines of the type C, and lines of the type B. Why did I call them lines S, C, and B? Because some lines have to go to a simple derivative process that we're going to call simple derivative. There's some other lines that we've called them C. They're going to be deviated to another class of process that's called continuous confluential derivative. And there's lines of the type B that have to be sent to the batch confluential derivative class of process. Okay, so in this class of process that's called causal, we're going to generate lines, and these lines are going to be sent to the simple process, the continuous process, or the batch process in order to manage or receive those lines and give them a specific treatment. Once this treatment has been performed, those processes are going to send the lines back to the causal process. So basically we're going to go back and forth. Each one of these classes of process are totally different, and they're going to give the lines a different treatment. I'm not really worried about the logic in the process, but I am worried about everyone understanding the specific scenario and what each process is doing with these lines. Okay, so it's not important to pay attention to what a process is doing. It doesn't matter if we're cutting someone's hair or if we're building chairs or tables. The example doesn't really matter. What is important is the type of treatment that we're trying to give each line and how we're moving the lines from one process to another one. So here we have our first causal process. Basically, we know that here we're creating lines and we're sending them to other classes of processes. And once those instances of those classes give these lines a specific treatment, they send the information back to the causal process. Then let's talk a little bit about the simple derivative class of process. This one is initiated each time we generate lines of the type S. Okay, so we have a one-to-one relationship. In the causal process, we create certain lines of the type S, and they're deviated to a start message event in this class of process. When the treatment is complete, these lines go back to their source, to the process in which those lines were created. So they're going to go back to this one here. Okay, so this first example is quite simple. We have lines that are generated here, they're sent to this other process, and once they've been treated, they go back to their causal process. Down here we have another one, it's called continuous confluential derivative class of process, and this one is always going to be active. It's always going to be waiting for the lines of the type C to be created in this class of process, of course. And once they've been created, they're going to be deviated to this one here. When the treatment is complete, the lines go back to their causal process. So practically the same as this one, but here we have a difference. Here, this class of process is always going to be active. The flow is going to be stopped in an intermediate message event, and the flows are going to be entering this intermediate message event. They're going to be treated, Once their treatment has finished, the lines are going to go back to the causal process. And here we have another one. It's similar to the previous one we just explained, but it has a slight little difference. This process is always active. Okay, we can see it's exactly the same as the previous one, where we also said this process is always active. But in this case, it says it's waiting for the lines B to be created and deviated from the causal process. This would be exactly the same. But this one here, it's waiting for the lines of the class C to be created and deviated from the causal process. Okay, so until here, it's quite similar. The only thing that changes is the type of lines that are going to be deviated to this class of process. But now the difference comes in this second phrase. It says, only the lines that are being processed, they're only going to be processed when there's a batch of at least 100 lines. So in this class of process, what I'm going to do, I'm going to create a batch of 100 lines. And once I have that batch, I'm going to start processing those lines. Once they've been processed, I'm going to send them back. So here we're actually creating batches. And until we have a batch created, we're not going to start processing them. Once the treatment is complete, the lines go back to their causal process. So this is something all the derivative processes have in common. This one is sending the lines back, this one is sending the lines back, and this one is also sending the lines back. Differences. This is a simple derivative process, so it's a one-to-one relation, and these aren't. These are confluential processes. One of them is continuous and the other one is in batches, but we have a one-to-one relation. So I'm going to continue with the explanation. It's important to try to follow it carefully. If you don't understand something, you always can pause the video, go back and try to listen again. So here we have an example. This is the causal process. Basically what's going to happen here is the process is going to start. And when we start this process, we're going to add several lines to the start message event. We can add 10 lines, 30 lines, 100 lines, 1000 lines, it doesn't matter. After that, the flow is going to enter this system task here. Once it's entered this system task, we already know that we can create lines of three different types, lines S, lines B, and line C. Let's imagine this is a column of a simple selection type inside of the group of fields, where we say, what type of line is this? And we can select S, B, or C in each one of the lines of the group of fields. So now let's say we have 10 lines of each type, or 100 lines of each type. Then the flow goes to this DO gateway, and this DO gateway is going to evaluate the containers that we previously filled up. So here, this transfer system task is going to grab all the lines from the group of fields and separate them in three different containers. Once I have them in three different containers, the flow is going to continue forward to this DO gateway, and this DO gateway is going to evaluate. Okay, first outlet. Is there any lines in the container C? If the result is yes, then the flow would go through this outlet. The same thing happens with the lines that are in the container B and in the container S. Why are we using a DO? We're using a DO because let's imagine that someone in the start message event only adds one line of the type B. In this case, the flow would only go through one outlet. This is why we're using a DO, because a DO allows us to move the flow through these different threads depending on the content of the group of fields, and maybe one or more outlets could be valid. Now, what's going to happen once the deviator system task deviates to the other classes of process? We're going to stop the flow and we're going to wait in these intermediate message events. Now, here it's important to take into account that we've added a subprocess. Inside of this subprocess, obviously, there's going to be several objects. We haven't represented them here in this image, but we'll explain it a bit later on. Basically here we're deviating, okay, with a system task, and we have some other controls that we're going to see later. Well, let's continue with the main process. Let's not enter into the detail of these subprocesses. So here we have an intermediate message event. Let's say the lines, we do have lines in the C container, so the deviator has deviated them to another destination process, and it stopped here in this EM. Now we have to take into consideration if the M has to be automatically reactivated. So if we're going to be receiving information from other processes, if we're going to be receiving lines from other processes more than once, we need to make sure we've set up the EM to have automatic reactivation. This is not important if we say, okay, we send once and then we receive all those lines back and then the flow continues. Now we don't need automatic reactivation because we know that never again is there going to be flow entering this EM. But in some scenarios where we say, okay, I've deviated lines, for example, to 25 different processes, and I need those lines to come back. And they're not going to come back all at once. Maybe one process is going to send them back in one moment in time. 5 minutes later, maybe another process is going to send lines back, and so on. Well, then we do need automatic reactivation. Now, what's going to happen with these lines enter when they come back? They're going to enter, they're going to unblock the intermediate message event, and the flow is going to continue forward to this transfer system task. And this transfer system task is going to load all the lines that were in the C container that have already been treated by the other external process. It's going to transfer those lines to a container that's called returned, for example. So we know that those lines have already returned from that external process. And afterwards, we're going to evaluate that container. So do we still have we already processed all the lines in the container C? If we have, the flow could continue this way, and it could wait in the CO. If we haven't, then the flow would just stop here. That's all that's going to happen. We're going to stop the flow there. Why? Because we still need the process to be active in order to receive more lines from other processes. So if this is the case, if we don't have all the lines of the container C already returned from other processes, then we cannot send the flow here. Because after the CO gateway, what we're going to do is finish the process. And we don't want to finish the process unless we make sure that we've already given all those lines of the container C the specific treatment that they require in the external process. Okay, so here we understand more or less how this thread goes, but all the other ones are quite similar. For example, if we have lines in the container B, we're going to deviate those lines to another process, and then we're going to stop the flow here and wait for those lines to come back. In this case, it says that it's a confluential process that manages these lines by batches. So once the batch with those lines come back, the flow is going to continue. The transfer is going to move those lines from the container B to a certain container where it indicates that they've already received their treatment. And if all of the lines have received their treatment, the flow is going to continue. But if there's still some lines that are pending to receive their treatment, we're just going to stop the flow. In this example, it's a little bit different because here we're only going to send all the lines to a single derivative process, and they're going to come back all at the same time. So let's say it's never going to happen that we have lines pending to be received, because once we receive the lines, they're all going to be sent back at once. Because here we have, it's a single derivative process where they're all going to be treated at once and they're all going to come back at the same time. So in this case, I can directly send the flow to the CO. I don't need a transfer system task because I know that these lines, these type of lines of type S, they're not going to be sent and then maybe they're going to send me back only 3 lines or 6 lines. I know if I send 100, the 100 lines are going to come back. Okay, so in this case, I don't have to have that security, this preparation, this additional preparation, just in case the lines are coming little by little. Okay, so this is the main explanation for the causal process. This is how it's set up. It's important to try to remember this. And now we're going to see some other details. For example, we're going to see how this subprocess is working. So what's inside of this subprocess? Here we can see what the deviation subprocess is going to do. When the flow enters the subprocess, it's going to activate this uploader system task. And this uploader system task is in charge of going to look for the reference of the destination process and bringing that reference to the panel of this causal process. Obviously, we have to try to deviate to 3 different processes, to the class of process S, C, and B. But we only need the reference of the class of process C and the class of process B because the class of process S is a simple process. It's a one-to-one relation, and we're going to deviate to a star message event. So we don't need the exact reference of each instance. But in the case of the class of process C or B, we do need the exact reference because they're processes that have already started, they are already triggered, they've already been launched, and they have a unique reference. And we need that reference in order to deviate the lines C and the lines B to those exact instances. So this uploader system task is going to grab that reference and bring it to the panel of the causal process. Where is this reference stored? We'll see it later, but it's stored, for example, in a known family element. We can create a known family element. We store the reference there, or we could store it in a business rule. And this process is going to go, it's going to look for that element, it's going to look for that value, bring it to the panel of the process. And once it has that value, it can use it in order to correctly deviate to those derived processes. Now, once it has the reference, it's going to deviate. Once it deviates, the flow is going to go to this gateway here, and we're going to evaluate if the deviation was performed correctly or not. How do we know if the deviation was performed correctly or not? Because the deviation gives me a return code. If it's positive, I know that it was deviated correctly. So if it's positive, the flow is going to go this way, and the subprocess is going to end. If it's negative, it's going to go to this personal task here. So a person can check and see what's happening. So let's say this task here is going to be assigned to the person responsible of designing this class of process. So if there's any bug, if there's any mistake, they can check it and see what they did. Why didn't they configure the process correctly and why it's not deviating correctly? There might be a problem because maybe something was not correctly configured or we didn't take something into account. For example, maybe the destination process doesn't have the flow stopped in the intermediate event. Or maybe if we're deviating to a star message event, but we haven't changed the mode of that process, it's going to give us an error. Okay, it's going to give us a negative value. So we have to check these negative values and try to see what we can do to fix this or solve this situation. And then we can run another test. So if we want to retry, we finish the task, the flow goes into the deviator again, and then it tries to deviate again. If the second time it was positive, then it would go out this way. So this subprocess here is what's happening inside of this subprocess, okay? So this is the collapsed notation, and the extended notation would be what I just explained here. All we have to take into account in this scenario is that in the simple derived process, we don't need a specific reference. We're only going to need them for these two types of lines, the lines that require the C treatment and the lines that require the B treatment. For the simple treatment, let's say this uploader system task wouldn't be necessary, but I didn't bother to draw another example because it would be exactly the same, but without this system task. Now I'm going to focus on the simple derivative process. So this process is going to start each time the causal process deviates the lines to this star message event. So once the lines are deviated to this star message event, this process is going to be triggered. Now here, let's imagine the flow has entered into this object. It's gone down here. And in this subprocess, what we're going to do is we're going to give a specific treatment to these lines. So let's say 100 lines entered. They've all entered this star message event. And here we're going to give them a specific treatment. What do we have inside of this sub-process? It doesn't really matter. This is what I was mentioning earlier, that we don't have to focus on the example because here 100 things could be happening. Maybe they're preparing machines to cut the wood, they're preparing the machines that have to drill the wood, and then there's all kinds of activities that have to be performed in these lines. We could give a lot of examples, but this is not important. So in here, maybe we'd have a flow. Maybe we have the start of a subprocess. We have a gateway. We have some personal tasks, some human tasks. We have some system tasks. Maybe here on this other side, we also have a few. Maybe we also have more gateways. Okay, but whatever's inside, whatever we have inside of this process, of this subprocess, it's not really important. Okay. What I want to explain is that here this process starts. Here we give these lines a specific treatment. And once this specific treatment has been given, the flow is going to continue. And this deviator is going to deviate all 100 lines back to the source. So it's going to send the lines back to the source. Okay. So first they came in from the causal process. We treated them, we managed them, we gave them their specific treatment, and then this deviator system task sends them back. What do we have after this deviator system task? All we have is the control of the deviation to make sure it gave us a positive number and finish this process. If it gives us a negative number, we have to check the results and try it again. Okay? So this is quite straightforward. It's quite simple. Now let's take a look at the next one. So here we can see the process that's going to manage the lines of the type C. So when is this process going to start? It's actually going to start before the causal process is triggered. Okay, so the first thing we have to do, even before the causal process is triggered, is trigger this instance here. So we're going to trigger this instance. It's going to start, and the first thing it's going to do is going to grab the reference of this process. Okay, so let's say the reference is CON, whatever. Let's say the last number is 15, so it's the instance number 15. It's going to store this information somewhere so that the causal process can go there and look for that information. Okay, so it says the system task saves the process reference in a business rule or in a family so that the causal process knows where to deviate the C lines. Okay, so this is actually going to store the information. Let's say we're going to store it here in a certain record. And here we're going to have number 15. Sorry for my drawing, but with the mouse it's a little bit difficult. Okay, so we store the reference here. And now when a causal process is triggered, it can look for this reference. We already saw that. We had an uploader system task that was in charge of doing this. It looks for the reference and it brings it back to the panel of the causal process. Once it has that information, it can use that information to correctly deviate to this intermediate event. So let's say we deviate 100 lines in one causal process. Now, the flow entered here and it stopped in this intermediate event, waiting for lines to be deviated here. If it's very important that this intermediate message event has automatic reactivation. It must have automatic reactivation because there's not only one causal process. Maybe we have dozens of causal processes that are inputting information into this process. So let's say we input 100 lines in one causal process. Then the flow goes down here, and here we're going to give it the specific treatment for the line C. Again, this is not important. I'm not going to bother giving an explanation of what could be happening with these lines, but let's say lots of things could happen here. So in this process, there's several treatments and several things that are happening with these lines. Now, these lines are going to be treated one by one. And each time a line has been treated, it has to deviate back to the source process. Okay, so here we want to deviate. Let's say, for example, 100 lines entered. Here we've given treatment to 20 lines, and we want 20 lines to go back to the causal process. And then we have another causal process, a totally different one, that sends us in 50 lines. So 50 lines have entered this intermediate event. This means that we're giving treatment to 130 lines. Let's say of those 130 lines, we finished with another 30. Perfect. Maybe 30 belong to one class of process, or maybe only 20 belong to that class of process. So we have to send 20 back to one class of process, and we have to send the other 10 to a totally different instance. So these are going to the same source process, to the same causal process, and these lines here, they're going to different causal process because we can have a lot of causal processes sending information to this intermediate message event. And we're continuously sending back the lines that have been treated. I'm going to explain this subprocess more in detail later, but let's say that after this subprocess has been performed and we finish the treatment, we would actually just stop the flow here. And once we stop the flow, it doesn't really matter because this intermediate message event, it's still available. So lines can still enter. We're never going to finish the process. This is never going to happen. This is why we call this a continuous treatment, because this process is continuously treating these lines. Let's say we create another causal process and there's another 100 lines. And these 100 lines enter here. Okay? And then we have another causal process and we have one line and that line enters here. So we're continuously giving treatment to these lines. And we're continuously sending the lines that have been treated back to the source processes or to the causal processes. So this is the main scenario. Now we're going to see how to deviate the lines back. Here we can see an example of the subprocess that needs to return the lines to the causal processes. Remember, there could be lots of different causal processes, not only one. So basically, the flow is going to enter this subprocess, and this transfer system task is going to grab all the lines that need to be deviated back to the causal processes. And it's going to store them in a container that's called toDeviate. So let's imagine I have a container, and in this container, I drop all the lines in, and these are all the lines that have already received their specific treatment, and they need to be deviated back to the source process, to the causal process. So is there any content? This gateway is going to ask, is there any content in the container to deviate? Okay, this is the container to deviate. So is there any content? If it's yes, then the flow has to go down. If it's no, then the flow is just going to go to this FN and this subprocess is going to end. So let's say there is. So I do have content. So this deviator system task is going to try to deviate the lines back. But let's imagine that here we have a lot of lines. And let's say some of these lines have to be deviated to the causal process 32, and some other lines need to be deviated to the causal process 34, for example. Each one of these lines are going to have stored in a column. In one of the columns of the group of fields, we're going to store a return code. This is something we've already seen. We have a return code, and this could have a positive or negative number. So let's say that all the lines that were deviated to the instance 32 have been correctly deviated, so it's all worked. But the lines that have been deviated to the instance 34, these did not work. They did not deviate correctly. Okay. So what we're going to do here with this transfer, we're going to separate the lines in two different containers. Some lines are going to go to a container that's called deviated, and the other lines are going to go to a container that's called not deviated. Then this gateway is going to evaluate, is there content in the container deviated? Yes, well then go this way. Is there content in the container not deviated? Then go up this other way. Here, we're going to allow someone to see these lines. They're going to have to check and see what's happening. And once they've checked, we have to move those lines from this container that's called not deviated, and we have to drop them again into the container to deviate, okay? It's the same container we can see here that we prepared previously. So once we've done this, we can try to deviate again. Let's say the second time the deviation is performed correctly. So then here, all the lines would go to the container deviated, and the flow would only go through this second outlet here. Okay, what's going to happen when the flow goes through this outlet that says deviated? All the lines that are in the container deviated are going to change their status. We're going to upload inside of a certain column that the status is deviated. And after that, with this gateway here, we're going to check if all the lines have been deviated. How do we know if all the lines have been deviated and there's no lines pending to be deviated? Well, if in the container to deviate it's equal to empty, that means all the lines have been deviated. But if I still have content here, the flow is going to have to go up this way and just wait. Why do we have to wait? Because maybe here there's a loop or there's something pending to be deviated, so we cannot just finish this subprocess. Okay, so here we have the loop. We already know how this loop works. We also know what happens when the flow goes down here. If everything has been deviated correctly, of course, the flow is going to go out the FN. The last thing I want to explain is the process that has to manage the lines of the type B. So in this case, again, we're going to start the process before the causal processes are started. So first this process is triggered, and once it's triggered, it uploads the reference somewhere so that the causal processes can look for that information. This has already been explained. Now we stop the flow here. We're going to wait for the lines to be arriving. But here we're going to create a batch. Okay, so the flow initially, let's say 100 lines enter. They're going to go this way. The process by default is going to be open. And here, there's someone who's going to define the batch. Let's say this person is going to say, okay, I'm going to wait until the month of June to close this batch, or I'm going to wait until I have at least 1,000 lines, whatever. It doesn't matter the condition, okay? So let's imagine we have 100 lines. So once we have 100 lines, this person here says, okay, I'm going to close the entry of lines because we already have a batch that's big enough to work with. Let's say, imagine this is the factory. We want to build chairs and tables and so on, but we don't want someone to build one unique chair. We want to create a batch. So maybe this is the manager of the warehouse, and he says, okay, until I have a batch of at least 30 or 40 or 60 or 6,000 chairs, I don't want everyone to start working at the factory. So this manager defines the batch. Once he has the batch ready, he says, okay, now we can start working with the chairs. So the flow goes this way to the DA gateway. And here where it says B treatment, this is the specific treatment that these lines are going to receive. Okay, so maybe the wood needs to be cut, we have to drill holes, we have to glue the wooden parts together, and all that specific treatment that I'm not going to explain because it's not really important for the scenario. Okay, so here we're going to give a certain treatment. And here, at the same time, because we're seeing here there's a DA gateway, we're going to launch another process. Why are we going to launch another process? Because we just closed this batch. Now what's going to happen with the new lines that need to try to enter here? Okay, so let's say I have a causal process. It sent me 30 lines, or let's say it sent me, let's say 500 lines. Okay, then the flow entered this way. We had this task open here, and then another causal process sent me another 50 lines or another 500 lines. So now we already have 1,000 lines here. And let's say this person, this manager, so the warehouse manager, says, okay, I already have 1,000 lines, so I'm going to create a batch and I want to process it. So the flow is going to go here to this gateway, to this subprocess, and here we're going to start giving it a specific treatment to these 1,000 lines. And at the same time, the flow is going to enter this subprocess here. And this subprocess is going to launch a new process of the same class of process. So let's say here it says launch process start, and this is the process number 21. Okay, well, this subprocess here, what it's going to do, it's going to deviate and it's going to create a new start message event exactly the same as this one, but it's going to be the number 22, for example. Then the flow is going to continue. It's going to upload the reference in a certain record, and then it's going to do all the exact same thing as what this one is doing. All right. This is something I'm going to explain later, what this subprocess is doing. But right underneath it, we have a second subprocess. Why do we have the second subprocess? Because it is possible that between this moment here and this moment down here, okay, I know this is going to be really fast. It might be just less than half a second or a millisecond, very, very little time. But let's say in the meantime, another 500 lines entered. So now we created a batch of 1,000 lines, another 500 lines entered, and when the flow is deviating, it creates a new process. But now we have 500 elements, 500 lines that are stuck in this process, and we need to do something with them. So what this subprocess is going to do, it's actually going to deviate these 500 lines. It's going to deviate them to the EM of this new instance that was created. So this subprocess here is going to make sure we can deviate those 500 lines here, the 500 lines that aren't part of this batch. Okay? So by doing this, we make sure we can clean this process from any additional lines that were created and input into this intermediate message event. Because I know it's very, 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 very strange that something like this would happen, but we do need to know how to create a process that is never going to fail. And the way in which we can create a class of process that is never going to give us a mistake, here we're seeing a mechanism that we could use. So if between the moment in which the lines were input here and the moment in which we've activated this process with the reference 22, then obviously it's also going to be stored somewhere in a business rule or an old family element. Between these moments, it could be maybe 2 milliseconds, but in those 2 milliseconds, maybe these 500 lines have entered, and we have to know We have to do something with them. We can't just leave them here in the panel of this process and just forget about them. Okay? So it is important that after we launch the new process, and once we know that the intermediate message event is available, we deviate from this process any possible additional lines that have not been added to this batch. Okay, so this is what these two subprocesses are doing. This subprocess here is going to manage the 1000 lines. Okay, so here we're managing 1000 lines, and each time some lines are managed, they're going to go into this subprocess, and this subprocess is going to send them back to the causal process. Okay, so it's sending the lines back to the causal process. Maybe it's sending 20 lines, 30 lines, 100 lines, 150. Besides, there could be lots of causal processes. In this example, there's only two. One that sent us 500 and another one that sent us 500. Okay, and this is the batch that's being treated here. We don't have to worry about the other 500 because we know that this subprocess already created a new process, and this subprocess sent those 500 lines to the new process. So they're going to be managed in the new process. Now, what do I do with these lines that are already processed? I have to send them back to the causal process. So if I finish 20 lines and some of the lines belong to one causal process and some belong to the other causal process, well, I need to make sure to send these lines back to their origin, to the source process. Here we're going to see an example of the two subprocesses I was referring to a moment ago. It's just a little bit more graphical. So here we can see we were talking about these subprocesses. I'm going to explain them a little bit more in detail. So basically what's going to happen is this subprocess here would be this one here. This is the extended notation of this SP. Okay. Now, what's happening in this extended notation? The flow enters. And once it enters, it activates this deviator system task, and it's going to deviate to a star message event. Obviously, right after the star message event, the uploader is going to upload the reference somewhere so the causal processes can look for it. And here we're going to leave this intermediate message event available to start receiving new lines. Actually, the new lines that are going to be input into this intermediate message event, most usually, let's say they're always going to be receiving the lines from the causal processes, except if there was a batch in the previous process that needs to be sent to this one. Okay, and this is something that this subprocess is going to do. This subprocess down here. So what we're going to do in this subprocess is we're going to prepare with this transfer. We're going to prepare all the lines that were not transferred. So here we've created a container. It's called not transferred lines. We're going to drop them, all the lines that haven't been transferred. Okay, those 500 lines I was mentioning earlier, they're going to be dropped into a container that's called not transferred lines. After that, we're going to look for the process reference. We want to bring the process reference to the panel of the process, of the previous process that we had, because let's say here we've got two processes. We have the first process that was launched and the flow is already here, and we have the second process that's launched that has the flow stopped here in the intermediate message event. So the first process that was launched needs to bring this reference to the panel of the process. Let's say the first process that was launched was the process with the reference 14. So in that process, we need to bring the reference of the process 15. And afterwards, we're going to use that reference in order to deviate those 500 lines to this intermediate message here of the instance 15. And here we're going to have a control of the deviation just to make sure everything is working correctly. And here we go back again to the previous sub-process that we already explained. I'm not going to explain it again. If someone wants to hear it again, they can always rewind the video and see it again. But basically, this sub-process that we're seeing here, it's being used. Let me go back to the presentation. Okay, it's being used here. Okay, that would be this subprocess. So how are we sending the lines back to the causal process? We're doing it thanks to this subprocess here. Okay, and I'm not going to explain it again because it was already explained previously. We can always rewind. Now we can continue with the exercise 307. We have to take into account that this is an advanced exercise, that not all of the information is in this exercise. Sometimes we're going to have to look back at all the things that we have done previously, the uploads that we've already been using, the transfers that we've been using, the deviators that we've been using, And we have to use all that knowledge in order to configure the scenario that appears in this exercise. Thank you for your attention.